Hey, and welcome to this webinar. My name is Ole Martin, and here with me I have
Ryan Daly.
yeah, and in the backstage here we have our technical expertise, Thomas, in charge of the cameras, lights, and everything else. So me and Ryan, we're working as technical consultants here at Building Point Scandinavia, doing programming and services for our customers. We work with Tekla Structures primarily, Jimble Connect, and other products. I'll be just doing a quick introduction here. This is a half-hour webinar. We will be able to receive questions during the webinar. However, this will be largely summarized at the end. So we will have some minutes at the end where we will go through questions. But feel free when it pops into your mind to ask them in the chat, and Thomas will relay them to us. The agenda is to present a new product, have an overview, demo, and go a bit more into depth of the functionality of this product.
We want to make sure we're giving people something extra if they've already seen the videos about this product before.
Yeah. And just gonna say a bit on who we are. We provide software solutions, field technology, and some hardware solutions for augmented and mixed reality. And at the core is BIM. So we have products producing BIM models, viewing BIM models, and also within the same environment, using these models to view them in mixed reality or augmented reality, doing scans, comparing scan to model, and in addition to doing services, having software products and hardware products, we also specialize in the workflow where models and information are created and is flowing through our programs and solutions and being utilized by different stakeholders in the project. And this product is very much in tune with that because it's very centralized around information, IFCs, giving the user flexibility to create the IFCs that they need. So I'll just hand it over to you, Ryan. You're the one who has made the product.
Absolutely. So people are expecting more and more from IFCs these days, and they want to be able to control more of what an IFC is. But the problem is Tekla Structures is a bit limited in how they can make IFCs. So there's standard properties that are exported from Tekla, and they can't be modified in the current state. And users can add additional property sets, but as I said, they can't modify the defaults. So yeah, what exactly am I talking about? So if I go to Tekla and I go to export an IFC file with just the normal settings, we can go and we can inspect that model in Trimble Connect, and we can see there's a bunch of things I didn't necessarily expect to be there. Yeah, I didn't set up these settings, they're just there by default. So we can see that these property sets, Tekla Common, Tekla Quantity, pset column common, they're just exported from Tekla and I can't control them. And same with these attributes, description, object type, owning user. I'd like to be able to change those, but Tekla doesn't give me the option. So that's largely what we're talking about today. Giving the users the ability to modify those very things.
Yeah.
And we were hearing from the users that they want to be able to change these things. Users were saying it's not possible to remove properties, it's not possible to change the values if they were exported incorrectly. I can't modify building story information, and I can't customize attributes, amongst many things related to these issues.
And these things arise from higher degree of demands put on those creating IFC models using Tekla. There's more detailed demands, and we see that the current functionality makes it, we need something to more easily meet those information requirements now coming to IFC models?
So we set out to develop a product that allows us to do those very things. Modify the default property sets for both normal entities and spatial elements. And spatial elements are buildings and building stories. And we also wanted to make sure you could do it for a filtered selection, so you could do it for specific groups of objects. And so this application allows you to remove properties that you don't want, again, and change values of ones that are already exported but maybe don't have the correct value, and also add new properties. And this is all done through post-processing of IFC files. We found that the Tekla API was a bit limiting, so to get complete freedom and complete control to the user, we post-process the IFC file after Tekla exports it. So Tekla exports the IFC, then it connects to the IFC Post Processor, but it's still connected to Tekla Structures, so that users can map values, and they can take values from other places in their model and insert them into a new place. And so it gives them a lot of power. So now we're going to move on to the next section, which is a quick overview demo. This is going to be pretty quick, but then we'll go into more detail and try to explain each section after that, because there's some kind of complicated subjects. So here I just have a sample Tekla Structures model, and I'm going to open up the IFC Post Processor and the extensions and components. And when you first start it up, it looks pretty blank, and that's because I haven't selected anything. I haven't set any settings yet, so everything is correct. And I have to select which IFC model I'm working with. Is it a 2x3 or an IFC4? And I want to modify my beams. And I want to modify only the steel beams, so I apply the selection filter of steel beams, and that's a Tekla Structures selection filter. So it's automatically connected to my Tekla model, and I can choose from my user-created selection filters. So for the steel beams, I want to change the name. So I'm going to just type in steel beam, and that's going to be applied to all the steel beams in the project. Change all their names to steel beam. And I also want to change the description. And I want it to include information about materiality. And to do that, I'm going to map the property material by enclosing it in percentage signs here. So that's the syntax. And we'll come back to this later, so don't worry if that's confusing. But the property material is now being inserted into the description. And these are all the default property sets for beams. We can see Tekla Common, Tekla Quantity, and pset Beam Common. And I want to remove some of those properties. And I also want to change the value of other properties. So I just removed reference and load bearing. And now I'm also going to change fire rating. Just going to do a new value of new fire rating. And I'm also going to add a new property to this property set. So I do that by manually typing in the name of the property set I want to modify. In this case, it's pset Beam Common. And then I'm going to type in the name of the new property, steel type. And then again, I'm going to map the material property to this new property. Again, we'll come back to what mapping means, but it's a dynamic reuse of the Tekla property on a new property.
And this will also work for any UDA you have in your Tekla Structures model.
Or report property, or
And mixing text and referencing properties and adding your own compound string there.
Exactly.
Yeah.
All right, so now we're just going to open up Trimble Connect to verify that all those changes have been made correctly. So the name has been changed, and we can see that the description is changed. S35 steel is now in the description, and we can also see some of those properties are removed, as well as my new property steel type is added. And it was not done to concrete beams. It was only executed on the steel beams.
Yeah. And this increases the level we can map properties to objects. In the standard IFC export, the filtering level is on the IFC entities. So within IFC beam entities, we can now differentiate according to our Tekla selection filters.
Exactly, and that's because each IFC entity type has different settings and different P sets that are exported by default. So it doesn't necessarily make sense to mix them, at least when you're talking about properties. So yeah, now we're going to go down and break down some of those more complicated subjects like mapping and selection filter usage and that type of stuff. So we showed you jobs, but what is a job? It's a selection of its objects plus those settings that you want to modify for those objects. And the way that you select objects, as Ula Mathan just said, is by combining an IFC entity with a Tekla Structures filter. So in this case, you can see I'm combining column with a concrete filter, but I can make multiple jobs for columns. So you can see a filter for steel, filter for column, and then an unfiltered job as well. So I can apply settings to all the columns, like I can change all their names. But then I can go in and I can add specific properties to steel columns, specific properties for concrete columns. And also you can see that we've set up jobs for beams as well. And you can set up as many jobs as you would like.
And as we create jobs, we are adding them to this job dropdown. And if I understood correctly, when you select a job, and enter values for attributes and the properties that's applied to that job. So we're doing a setting up properties and rules for the selected object group. Yeah.
Exactly, and I think this will explain that in a little bit more thoroughly. So we have a steel beam job here, and I want to add a new property to pset beam common just for steel. So it's a steel type property. And then I also want to make a job for concrete beams. And we can see that, okay, now the properties I made for steel beam aren't there anymore. But now I'm going to add some for concrete. So it's like a selection of the objects plus the settings for that selection. And we can see, okay, the concrete beams have the name concrete type, whereas the steel beams have the name steel type. So your property names and values can both be dynamic.
Yeah, we have now done within IFC beam entity created rules and properties on different objects within IFC beam and also mapped values gotten from the Tekla model and placed on the IFC.
So, and we've mentioned mapping several times, but what do we mean by mapping? And when we say mapping, to us it means assigning values from one place to another. And in this application, it also allows you to combine multiple values and put them in a new location. So, and this can be using your UDAs to replace properties that are maybe incorrect or not how you wanted them. You can combine multiple UDAs to create a long description or a long name or something. And you can also replace attributes that were maybe difficult to modify one by one in Tekla. So again, combining multiple properties into one, what we mean is, and we're also talking about post-processing. So we have to remember that we're taking properties from a place in the Tekla Structures model and then putting them into the IFC model. So in this case, we're taking two properties and we're trying to insert them into description. If I want my description to ultimately read like this, column made of S235 JR steel with an HEA 300 profile, I can do that by mapping the Tekla material and the Tekla profile properties into the place I want in this description. And the way I would write that is something like this.
Yeah. And for each object, the post processor fetches the correct property from the correct object and places them correspondingly in the IFC.
Exactly. So that isn't to say every beam is going to have S235JR as the material. It's going to pull the material value from every corresponding object, every corresponding beam. And so we'll just do one more example of mapping. So if I create a column here, and it's actually just showing exactly what was on the previous slide, column made of material steel with a profile. It reads in kind of a weird way, but I think it takes time to get used to writing like that. But we can see it reads correctly in the end. Column made of S235 JR steel with a HEA 300 profile. So now we'll talk about IFC spatial elements. We've heard a lot of users asking about this type of thing. Can we change the name of the building stories? Can we change the name of the site? And can we add properties to these?
And these spatial elements play an important role in the IFC because most viewers use this spatial element hierarchy to navigate in the model, to find the correct section in the correct floor that's defined in this spatial hierarchy as these elements.
Right. So some people have asked me, can you use this to make new buildings or new sites? And this application this Tekla extension is not designed for that. It's just designed for renaming or adding a description or modifying spatial elements that already exist. So you still have to use Tekla Structures to the organizer to break down the model into spatial entities.
So any information requirements that are to be put on those elements, this product will allow the user to achieve that.
Absolutely. You can add additional information to spatial elements. And so we'll show an example of this, and it's moving pretty quickly because I'm typing really quick, but I'm opening up site as a job and then changing the name, changing the description and the long name. And then I also want to change the building. So change the building name description as well. And when we move on the building stories, the way that you select which building story you're working with is by the elevation of the building story. So that's kind of the filter. So the building story at 3,500 millimeters is the building story I'm going to work with now. And we can see now in the Trimble Connect that it has in fact changed the name and description to how I set it in Tekla or in the IFC Post Processor. Okay. And the last thing we wanted to talk about is settings, which is to say that you can save everything that you've set up in the IFC Post Processor for reuse in another project. And that's because the way everything is designed is based on filters and object types. So it doesn't necessarily need to be connected to one model. So I just have two jobs set up for beams, concrete beams and steel beams, and I'm going to save it as concrete and steel beams settings file. And where that's saved is in your environments folder. So the IFC Post Processor is installed in the environments and then extensions folder. And the settings are saved in that same folder as a JSON file. And that's powerful because it allows you to access it from different models with ease, just automatically. It'll load those into your dropdown. So now if I open up another Tekla model and start up the IFC Post Processor, it automatically has all those different settings I've set up in the dropdown. It makes it pretty easy to work with multiple models. And it may be tedious to set properties one by one using this application, But the idea is then it's easy to just never have to set them again necessarily, because you can always load the settings.
Yeah.
So the business model for this is we are giving free trial licenses. You just have to go to our website, and I'll show you that in a second. And then the costs for this application scale based on the size of the company. So we really want people to talk to one of our sales representatives, and we can give them a quote based on how many engineers they have using the program. So again, I'll show you how to find this information. You can go to the warehouse and find the IFC Post Processor, and there's a link to Building Point Scandinavia website. It takes you right to the IFC Post Processor page on our website. And at the bottom, there's a request trial form. And we really want people to fill out this form, and we'll immediately send you a free trial license. And I also wanted to point out that when you download the program, we have a nice user manual that explains everything that we've talked about today and more. So if people have questions about some of these more complicated subjects, like perhaps maybe the mapping that we talked about, it's thoroughly explained in this manual as well. So there's a lot of resources out there for people to access. Yeah. And that's everything we wanted to show for today. So if anybody has questions, or we'd be more than willing to answer them now. But Thomas is shaking his head that nobody's saying anything in the chat so far.
We can perhaps mention some examples of the use cases where this product is shining. I mentioned it before, but we're IFC entities will have increased information requirements. So for example, the name is to be consisted of different codes, and to have several places on an object to have defined those codes, get them all, put them together as per the BIM requirement is now possible. And also these descriptions on not only objects but spatial elements has now been unlocked. And also like to summarize the increased filtering within IFC BIM. You can choose to differentiate between material, profile, and other any filter actually, which you can create in Tekla. And that really makes sense because within the IFC schema, you have property sets for concrete beams and for steel beams, and you will get timber. And to be able to differentiate your property setup and mapping, it's something that we see our customer needs.
Yeah. Yeah. Builders want different information depending on if it's a timber beam or a concrete beam.
Yeah. So, which Tekla versions is this compatible to?
2019 and up. So Tekla 2019, 2020, 2021, 2022.
Yeah. That should give good coverage. We know that some projects are running on perhaps even older than 2019, but that coverage should cover most.
Yeah.
And also a question here. When we choose the IFC type, it's we choose between IFC 2x3 and IFC 4. 4.3 is the question is about the support for IFC 4.3.
Yeah, it's not entirely supporting IFC 4.3 yet, insofar as any of the new features of 4.3. So it's designed for 4.0. And so it'll mostly support 4.3s, but there are some new changes to the schema that aren't quite supported yet, but we'll be adding that in the next version of the IFC Post Processor. Just talking about the differences between IFC 2x3 and IFC 4 really quick. In 2x3, if I look at, I just want to exemplify the differences. If I look at beams, we can see that there's 3 property sets: Tekla common, Tekla quantity, and pset beam common. But if I switch to IFC 4 and I look at beams again, we can see that the property sets are different. So now I have QTO beam-based quantities, and I don't have Tekla common and Tekla quantity. So, and that's why the settings are not shared between them. Is they're entirely different property sets.
We also have a question regarding if one has a Excel spreadsheet with a lot of information that needs to be added as UDAs in the Tekla model, for example, on reinforcement, based on some rule, for example, position number. Would this be able to do in one go? This it is currently getting information from Tekla, the Tekla model. Could it also get information from an Excel spreadsheet?
Well, as you know, we've been talking about this quite a bit, and this is another application that we want to develop and is currently in development, but it's not a part of the IFC Post Processor.
Yeah, the main purpose is for the Tekla Structures IFC export to be able to fulfill these more advanced requirements. So the information from the Excel would in this case be imported in one operation, and once it's in place on UDAs, you can set up your filter, have your job be the correct IFC entity, IFC reinforcement perhaps, along with a selection filter, filtering on your position number, and you can set up your rules. So if the rebar object has this Excel property coming from Excel, then it would be possible to set up a job with a rule getting that one.
Yeah, I think it's in the pipeline for us, and it's just not quite there yet. It could also be possible to set up your settings using an Excel file, but right now they're saved as a JSON, so that's possibly could be integrated into the IFC Post Processor, but we'll see as we continue to work with that.
Yeah, and that is that concludes this webinar. Any further questions? Just let us know. Take contact. We're available. And yeah, thank you for your time.
Yeah, if you fill out that form on our website, you will get in direct contact with me, so I can answer any questions you want to email to me directly.
Thanks. Good. Det var det.